Hey guys, and welcome to lesson 5.6, the basic properties of logarithms. So recall from the last lesson that the inverse of an exponential relationship can be written as x equals b to the power of y, where we actually exchange the y and the x, and that expression can be rewritten using logarithms as y equals log x base b. And a couple of things to remember is that b is always greater than 0, b will never be equal to 1, and x is also greater than 0. So what we're going to do now is look at more examples. The first one we'll evaluate is log of 9 squared base b. So what we're going to do in this case is we're going to kind of develop a rule. So the way we're going to do that is take a look at the log with its base 3, and because the log has base 3, I'm going to change the argument, and I'm going to rewrite that as base 3. So 9 is really 3 squared, and that 9 is also squared. Okay, so what happens here is that this becomes log of base 3, and then the argument is now 3 to the power of 4. Now, the reason I chose to write both the base of the argument and the base of the logarithm to be the same is because, as you saw in yesterday's lesson, that the answer for this would just be the exponent here, which is 4. So as a general rule, whenever the base of your argument is equal to the base of your logarithm, then the answer is whatever the exponent is. Okay, so in this second example here, before we develop a rule for it, let's find out what the answer is and see if we can find a pattern. So if I were to write this out in exponential form, let's say our answer here would be y, I would say that 8 to the power of y would be equal to 2. I know that if I took the cube root of 8, my answer would be 2. So I know that my answer to this question here would be, so how did we get the 1/3? Let's take a look at our logarithm, and we notice that our argument here is base 2, but the base of our logarithm is 8. We can rewrite that 8 to be base 2. So we'll change it to log 2, and then our base we can rewrite as to the power of 3. As a general rule, when, again, the base of your argument is the same as the base of your logarithm, the answer is not just the exponent up here, but it's this exponent divided by this exponent. And that is how we get the 1/3. Actually, the same rule applies up here. Because it was 4, and then the exponent here is 1, we just did 4 divided by 1, that gave us 4. So, as a general rule, when you can rewrite both the base of your argument and the base of your logarithm to have the same base, the answer is just this first exponent divided by the second exponent. Alright, let's move on to example C. So again, our goal here is try to get same bases, both in the argument and in the base of your logarithm. So let's rewrite this. Let's rewrite this argument as 1/7 to the power of 1/3, because we are taking the cube root of 1/7. The fact that this is a fraction tells us we can rewrite our exponent as 7 to the power of negative 1/3. And now, because our argument's base is 7, let's see if we can rewrite the base of our logarithm as 7 as well. So I'll say that this is log 7 squared, and then our argument is 7 to the power of negative 1/3. So based on the rule above, our answer would just be the first exponent divided by the second exponent down here. So our answer would be negative 1/3 divided by 2. And now basically what we have here is fractions over fractions. So I'll take my numerator and multiply by the reciprocal of the denominator, which gives us a final answer of negative 1/6. Our final question for this page is log 25 base 5 plus log 125 base 5. So what I notice here is that our arguments and our bases can all be written as the same base. So for our first term here, I'm going to rewrite it as log with base 5, and then I'll change the argument to 5 squared. And for our second term, I'm going to write it as log base 5, and this time our argument will be 5 cubed. Now using the rules above, I know that this first term is just 2 divided by 1, so exponent divided by exponent. Same with the second one, so exponent divided by the exponent 1. And so our final answer here would be 5. Okay, so in question E, we see that natural logarithm occurring here. So whenever you see ln, that is really the equivalent to logarithm with base e. So I'm just going to rewrite ln as log base e, and then our argument here is 1 over e squared. So what I'll do now is I'll take my argument and I'll write it as e to the power of negative 2. And again, because the base of my argument equals the base of my logarithm, I can just take exponent divided by exponent 1 here, so the answer here would just be negative 2. Okay, one more rule to develop, and we'll develop it using this example here. So we have base 4, and our base 4 has an exponent that is a logarithm. So we will work on that exponent. So the exponent here, I have base 4, and I can rewrite 1 over 16 as 4 to the power of negative 2. Now again, just looking at the exponent, the answer to my exponent here, if I were to evaluate it, well, the bases are the same, so it's just negative 2 divided by 1. And then if we evaluate this, well, 4 to the power of negative 2, that is just 1 over 16. So you'll notice here that if I have an exponent that is a logarithm, and the base of that logarithm happens to be the same base, as our power here, then the answer is just going to be this argument here. So, as a general rule, when our bases are the same, the answer is just the argument. So with all those in mind, let's go ahead and solve for x in each one of these cases. Now, in example A here, we have just log x, and we don't have a number here, so again, we imply, or it is implied, that this is base 10. So what I'm going to do now is rewrite this in exponential form. So, okay, we have our base 10, and we raise it to the exponent 3, and that will equal our argument. And we know that 10 to the power 3 is just 1,000. Again, to solve for the argument here, we're going to change to exponential form. So base 8 raised to the power of 2/3 equals our argument x. Okay, whenever we have a fractional exponent, the denominator goes out front, so we're going to take the cube root of 8, and then we're going to take the answer of that and square it. When we go ahead and do that, well, the cube root of 8 is just 2, and 2 squared ends up being 4. Alright, in part C, this time we're trying to solve for the base. Again, we can write this in exponential form. So our base to the power of 4 equals 81. Now, if I want to solve for x, I'm going to take the 4th root. So I'll take the 4th root of 81. And normally whenever the root is an even number, you can take the positive or the negative. So I can say that the 4th root of 81 is plus or minus 3. But just be really careful here, because we're actually going to ignore the negative answer, because as we said before, on the first page, our base is always greater than 0. So just as a final answer there, x is just going to be 3. Okay, and one more, again, always going back to changing into exponential form. So our base to the power of 2 equals our argument, 3x plus 1. Well, we can evaluate that. 4 squared is just 16. So what we have now is this nice linear equation. I'll bring the 1 over. So 15 equals 3x. Divide both sides by 3. And we have x equals 5. Okay, so that is it for today's lesson. And as always, if you have any questions, please make sure you ask in class. Take care, guys.